Hello. Any questions before we start? Nobody's feeling like asking the question. There is one question that you all wish you had the courage to ask, but you're too scared to ask in front of the class. Nobody's feeling courageous today? What's your name? What's your name?
My name. Oh, sorry.
Say it louder. I can't hear it.
My name is
Robert Johnson?
Obed.
Obed.
Yeah.
Obed. Obed is the only one with the courage today to ask the one question that everybody's wondering about. Good job. Why is that? Why are you the only one that has the courage to ask this question in front of the whole class? Does anybody understand that? But everybody's wondering, everybody here is wondering about this. But only one person is willing to ask. So I made a poll, and 5 students voted for March 7th, and then 90 students voted for March 14th. One of these students is me, by the way. So yeah, it's been extended until the 14th of March. And if somebody can explain to me why this gentleman was the only one that had the courage to ask out of everybody, they get extra 10 points. Extra 10 points on the assignment, because I would love to know the answer to this dilemma, if you want to call it that. Okay, any other questions before we start? Probably somebody is wondering if I can connect my psychic powers to the universe. I think somebody's wondering, when can we submit on Moodle? I think somebody was wondering this. And the answer is now. There's a submission link on Moodle for the PDF to submit that. So it's possible to submit. So if you like the March 7th deadline, you can still submit on March 7th. Any other questions? Good. Okay, if there are any questions, feel free to interrupt or raise your hand at any time. And yeah, I can try to answer them. So today we're going to talk about qualitative research methods as kind of an introduction to this topic of qualitative research methods. Remember, we had an introduction to quantitative research methods. We had an introduction to visualization. And today is another introduction to qualitative research methods. Again, this is an introduction, and you could take a whole module just on qualitative research methods. So we looked at quantitative research methods already, visualization methods, and now we will look at qualitative methods. So quantitative methods are generally an analysis of numerical data. That's how we characterize quantitative methods. And then qualitative methods are an analysis of anybody know what qualitative methods are an analysis of? What kind of data? Anybody already know? Good. Actually, I would call images quantitative. I would call those quantitative, generally speaking. But you can run, I would say you can analyze images with both quantitative methods and qualitative methods. Anything visual, so anything visual can be analyzed with both kinds of methods. The qualitative is really targeted at a special kind of data. Anybody know what that might be? Special kind of data, qualitative analysis. Ethnography is a kind of qualitative research method. So what we're really targeting is natural language. So qualitative, I have to sometimes slow down and think. Qualitative research methods target natural language and natural language data, generally speaking. So we have numerical data and we have natural language data. That's kind of what we're dividing the world. And we also have mixed methods, things that can span both, like linguistic variables and fuzzy concepts. This is a funny topic. So remember, the bigger goal is to expand our knowledge, right, of the universe. How do we increase our knowledge of the world? For example, how do we increase our knowledge about software or hardware or something that we're going to design that doesn't yet exist? Maybe we want to study the behavior of people and increase our understanding of the behavior of people. And here are some different ways we can increase our knowledge of the world. We can run experiments, right? Everybody's familiar with that. We can make observations, like setting up a camera somewhere and watching people as they interact with the world. We can just interview people. We can walk up to people and ask them their opinions about things or interview them. We can run a simulation. In other words, we can try to recreate the behavior in software and simulate the behavior and predict. We can analyze documentation and images. We can run a formal analysis like mathematical proofs. And we can design and build new things like software and hardware. These are some of the ways we increase our knowledge of the world. Just as a side note, what is knowledge? Does anybody want to try to define what knowledge is? Anybody want to try to define the word knowledge? That is a very difficult question.
An approximation to this world.
An approximation to this world. Any other guesses?
Any information or data that has the potential to be replicated and transferred.
Any information or data that has the potential to be replicated or transferred. That's not a bad answer. This particular slide is making a distinction between data, information, and knowledge. Your definition is merging the three. But it's still good. I still like it. Another?
Sort of like abstractions that we make about the real world.
Abstractions that we make about the real world. Yep, that you could use that as your definition of knowledge. This is a little bit of a side note, but I think it's good to just throw in there. In epistemology, everybody agrees that knowledge is valuable, but agreement about knowledge tends to end there. Philosophers disagree about what knowledge is and how you get it, and even about whether or not there is any to be gotten. So to try to define knowledge is very difficult. Most people agree that it exists and there is a definition of knowledge, but to try to nail down the definitions is very difficult. But this paper or this slide talks about it a little bit. Definitions of data, information, and knowledge. So data would in this table is a set of symbols. Information is data that are processed to be useful, providing answers to who, what, where, when, and there's no why questions. And then knowledge is the application of data and information providing answers to how questions. Is that what you said? Is that what you said?
Yeah.
Okay. Yeah, then that's the definition on this slide. These are old definitions, right? Here are newer definitions. Data. Computerized representations of models and attributes of real or simulated entities. Information is data that represents the results of a computational process such as a statistical analysis for assigning meanings to the data or the transcripts of some meanings assigned by human beings. And then knowledge is data that represents the results of a computer-simulated cognitive process, such as perception, learning, association, and reasoning, or the transcripts of some knowledge acquired by human beings. So it's a tricky topic. It's very tricky. I just thought it was worth mentioning because we're using these words, data, information, and knowledge, and they're tough to nail down, let's say. Okay, so here's a little table that tries to give an overview of the different kinds of research methods, quantitative research methods and qualitative research methods, into different buckets like experimental, observational, reports, and reflections. So in the quantitative category, we have, this is generally numerical data. So in experiments, we can set up the measurement of physical quantities, right? It's in a special experimental design. We can measure things in the world, so in the wild, I would call that in the wild. So outside of a laboratory setting, outside of a controlled setting. We can use things like eye tracking as well. And we can also use questionnaires with things called Likert scales, like on a scale from 1 to 10, what's your opinion of the following, to try to quantify the opinions of people. And then on the qualitative axis, again, this is, I always think natural language processing, typically using words, but could also be diagrams, pictures, and physical actions. So the corresponding experimental setup is usually a user study, so a very controlled environment where we're measuring things like task performance time or task accuracy, how accurate people are when they perform a task, or how quickly or slowly. Ethnography is where we observe people when they, in their actions and their behavior. We might transcribe a conversation, for example, or we might transcribe a talking out loud protocol. Autoethnography is when you try to observe yourself, try to observe your own, maybe keeping a journal. And then of course we have interviews and focus groups. Focus groups are groups of people with a special skill, right? And we have free text questionnaires and diaries and things like that. So that's a kind of little overview of some of the different research methods. And for all of these cases, you can go into a lot of depth. So there are books dedicated to every one of these topics. So before you conduct a study, some of you will conduct user studies or some sort of a study in your project. It's going to be up to you and your supervisor, basically, some sort of negotiation process. You want to understand what it is that you're investigating. Do you have one or more clear questions or hypotheses that you're trying to answer? That's a good starting point. Or are you trying to get a broader overview of how people engage with a topic? Sometimes there is no very well-defined question or very well-defined hypothesis. It might be just, we want to understand how people interact with this software. We want to increase our understanding of how people interact with this, or hardware, or software, or this device. It might not be a very solid or concrete hypothesis. Does anybody know what the magic word is for that kind of study? When you don't have a hypothesis or a specific question, there's a special word. Exploratory. How did you know that? Undergrad? Which undergrad? Geography. Here or somewhere else? Where was it?
Not relevant.
Not relevant. You don't want us to. You don't want to find out. Us to find out who you studied. Anyways, that's correct. Are you concerned with actions or, quote, inner behavior? Do you want to see how a person will do something, or do you want to know what they are thinking or feeling during it? Are you going to look for evidence in specific categories, or are you going to open to what participants say and then generalize? So before you conduct any study, like a full-scale study, maybe you want to engage 20 participants or 30 participants, you always want to test out your experiment on just 1 or 2 people before you actually conduct the study and see how it goes. Basically to work out the bugs, because your experiments will usually have some flaws. And if you just try to deploy it immediately on a group of 50 people, you'll find out that there are 50 errors. If your experiment involves people, how are you going to gain access to people? How are you going to engage them? And then, if you do want to engage users in your study, is the sample of users that you're going to engage a fair sample? Is it something where you can draw conclusions or generalize the conclusions, or not? Most of the studies, like in academia, are targeted at a very, very select few group, a small group of people, and a very select group of people. Does anybody know who that is? So when you read a research paper that involves users, it's usually a very targeted, select group of people.
Isn't that a focus group?
It's usually undergrad students or graduate students in all of the studies throughout the entire world. So that's actually a special group of people. So to make generalizations is questionable. It's questionable. Since every study in the entire world is just undergraduate college or university students or grad students, it could introduce bias, let's say. We might observe 30 people using a piece of software and assume that the findings will apply to subsequent users and are just anecdotes. And that's sometimes how we reach our conclusions. And one of the big questions is, how many people should you include in your experiments? I mean, generally speaking, when you start to see the same answers over and over again, that's how you know, okay, probably we have enough people. And how do you avoid unwanted bias in your sample? For example, it could be a special gender, age, or race, and so on. I mean, this joke about human psychology is the study of undergraduate psychology students. This can be generalized to every study in the entire planet, actually. It's the study of undergraduate students or master's students. It's not just psychology. I'm listening to a book right now, and it's written by somebody that's conducting lots and lots of user studies, a lot of them. And they're all on undergrad students. at a special university. So after your study, after you've gathered information, how are you going to turn that information into knowledge or, quote, findings? And there's those words, information and knowledge, again. But yeah, so try not to get too concerned about that. You often first need to get the information. I would usually call this natural language data. In this case, it's natural language data. So how do you get natural language data into a usable form where you could draw conclusions? That's tricky. If you just have a page of text and you want to draw conclusions from that text, how do you process a few pages of natural language text and try to draw conclusions from it? So for text, usually you have a transcription, right? If you're interviewing somebody, there's a transcription. It's usually anonymized, so any user study data that you collect is anonymized. How are you going to summarize? If you have 20 interviews with 20 different participants, how do you summarize them? So one of the ways to do that is by so-called a coding exercise. So in other words, coding, you are reading natural language and then you're trying to find the reoccurring themes. So there'll be some themes that reoccur over and over again, and you try to find and identify those reoccurring themes. Right? That's called coding. Annotating the original natural language data with thematic terms and extracting honest representative quotations from interviews. Does anybody see a problem with this approach? This coding, this idea of coding? So reading natural language and then identifying and picking out the themes that reoccur, or may not, or maybe singular themes as well. Can anybody see a problem with that?
It may not necessarily be relevant.
That's true. The themes might not be relevant. Any other problems?
I'll think about it.
It's a tricky question. If you know the answer to this question, your knowledge of research methods is high, I would say.
The person doing the coding brings their own personal biases to it, and they might have a certain outcome in mind, and so not potentially find other things that exist.
That's right. So imagine I have 20 pages of interviews, and I code the 20 pages of interviews. I find the themes, and I give the original 20 pages, we have 2 copies, to somebody else. Do you think the coding is going to be exactly the same?
No.
Yeah, it's not going to be exactly the same. So that's kind of a problem. You sure you don't want to share your bachelor's degree? Because it sounds like they gave you a good education, actually. You're not proud of your education? Like, I'm proud of my undergrad degree. Anyways, you don't have to share. But that's right. And there are software tools that can help with this. And the more people that do the coding, the better. So if you have like 5 people all participating, doing the coding, that's better. And then you can compare your coding results and try to get them all consistent with each other. Like find an agreement. And it's basically like a democratic exercise. If you have 5 people and you're all voting on themes, it's a democratic coding exercise. So imagine you have a survey, and the question on the survey is, why did you not take your medicine as the doctor requested you to? And you give this question to 20 different people or 100 different people, and they all give different answers. So each one of these replies has been given by a different individual. right? And the task is to find what are the themes, that reoccur. Could you classify these answers into different categories? Is that possible? And then you'd have to read them and try to do that. That's the coding exercise. So forgetfulness. So you would probably cluster all these answers, this one together with this one, with this one. Those are easy, right? That one you'd probably cluster into the same. In this one, you'd put them all into like I forgot category, right? But what about this one? Would you put that into the I forgot category? Some people might, right? If you're too busy, you get distracted. If you're too busy, you forget to take your medicine, right? So that's going to be up for debate, that one. I left the bottle at home. Is that like I forgot to bring the bottle with me? That's going to be up for debate too. This will be in probably its own category. Like I decided not to would be its own category. I was asleep. So this would probably be its own category too. Like I was unable to take the medicine, right? Because I was asleep. Yeah. And then this one might be, I decided not to, right? So anyways, you can see how this exercise might result in different answers and different codings depending on who's performing the task. And so that's when multiple people doing the coding will help resolve that. This is just a screenshot of this in vivo software. That's the natural language text that we're trying to process. And these are the different participants that performed in the interviews, right? We're processing a set of interviews. And somebody is going through and coding the responses in different categories. Natural environment, economy, infrastructure, and so on. So there are different tools that can help with this kind of task. And Nottingham has a subscription to this software in case you want to use it. So that's where some of your tuition fees are going, to paying for this subscription. So after you conduct this user study, you're usually looking for patterns, right? That's the whole purpose of the coding exercise. We might be looking for trends or outliers. So outliers are singular events usually. And look at the evidence. And you'll have to discuss bias with your supervisor, how to reduce or avoid bias. And are we really like finding new patterns? Are we confident that what we found is really a new pattern? So there's another term here, inductive. Qualitative research is often described as, quote, inductive. So what does that mean? Patterns emerge by looking at the data, developing a theory, whereas quantitative research is often deductive. So I've tried to summarize that here. Inductive is, quote, bottom up. So you can imagine the bottom of the hierarchy, you can imagine is data, like your natural language texts. You're starting at the bottom. And you read and code and analyze that data, which is very specific. And then you try to abstract it to a higher level, which is general conclusions. Deductive is top down. In other words, you start with general questions or general hypotheses, and then you generate data afterwards. So the order is different. with inductive, you start with the data and then you generalize and try to formulate hypotheses and questions and look for trends. Whereas in deductive, it's the other way around. You start with your hypothesis or your question. You run an experiment. You get data, and then you see if that data matches your hypothesis or question. So in this slide, it's called top-down. This is another illustration that's hard to understand. The deductive, I think, is easy to understand, right? That's the quantitative, usually the quantitative research. So we start with a theory, we formulate a hypothesis, we run an experiment. We've left out the run an experiment part here. Collected the data, analyzed the data, and then confirm or reject the hypothesis. The pipeline here for the inductive is very poor and hard to understand. But actually what we do is we start with the data. So this rectangle should be here. Collect data, then code the data, look for patterns and trends, and then draw conclusions. Yeah, that's the way that should be. But I didn't make this diagram. This is from somewhere else. But if I was going to make this diagram, it would look a little bit different. Okay, so a little bit more about the quantitative research methods, some generalizations, some general guidelines. Quantitative research is objective, whilst qualitative research is subjective. That's kind of a common viewpoint, let's say, when comparing these two different approaches. Quantitative measures of physical quantities have a consistency and reliability that reports and reflections don't have. But quantitative research also has bias. Can anybody think of a scenario where quantitative research has bias? Quantitative measuring things and producing numerical data? That's kind of an advanced question too, actually. So if you're doing quantitative research, you have to decide what to measure, right? And there could be bias in deciding what to measure. By making a decision about what to measure, you're making also decisions about what not to measure. And that could be a form of bias.
Just to add on to that, it's also, mostly when you're doing quantitative measurements, you need to also ensure that you try to have a controlled experiment. So all possibilities that you're trying to measure are equal. So you don't, so one thing is deciding, as you mentioned, the other thing is to ensure the object of research that you're trying to collect data from should not produce biased data by itself.
Yep, that's right. That's right. And I'm sure we've all heard different stories about AI producing biased results. Right? So there are always exceptions, right? Also, once we start analyzing qualitative data, we can use labels and categories that give it an over-formal sense of objectiveness. And things are not as objective as they seem, generally speaking. Another generalization is qualitative research is about discovering ideas, whereas quantitative is about testing them. There's some truth to this. So a common approach in qualitative research is called grounded theory. So you collect all of your natural language data first. Maybe you've interviewed 20 people, or you've conducted a survey of 1,000 people, or something like that. And then you start to do your coding exercises. And then you form your theories after you've collected the data. This is also called grounded theory. It's the bottom-up approach where you collect the data first, do your analysis, and then draw conclusions. And you can form hypotheses at the end of that process. And that this is contrasted with a hypothesis-driven investigation where you start with the theory first, and then you generate the data to support that. And it's also possible to begin a qualitative study from a definite hypothesis or a question. In computer scientists, including myself, generally love hypotheses. Generally, they'll start out with a specific hypothesis and then design an experiment that either confirms or refutes that hypothesis. And what ends up happening is they get results that they don't expect. And they have to form a new hypothesis and rerun another experiment, and it never ends. One of the first things we need to decide is whether a study is qualitative or quantitative. Often we use a mixture of methods. So it is very true. We usually often use a mixture of qualitative and quantitative. It's very rare that you only have one kind of research method in your projects. A simple example is a questionnaire with some numerical scores and some free text answers. If you have a survey or a questionnaire, there's always some kind of space where it says, do you have any other information you'd like to provide, or do you have anything that you think is important that we left out? So it kind of can collect data that you were not anticipating to collect. Also, one might be a precursor of another, so one experiment might be qualitative, followed by a quantitative experiment. So we might start with a numerical questionnaire, and then follow up with interviews that look at the results of the questionnaire. Another generalization, quantitative research is about making measurements of what is happening, whereas qualitative research is about asking people's thoughts and opinions. Right? That is a kind of a generalization. Sometimes good qualitative research can begin by asking people to talk carefully through what they are doing and to contextualize it, and then draw findings from this description. So you can imagine formulating a question that asks for a numerical answer, right, from 1 to 7. Or you can imagine asking the same question but without requiring a numerical answer. And you might draw different conclusions based on how you formulate the question. The order of the questions also makes an important difference. The order of the questions on your questionnaire and your surveys. Another generalization, quantitative research is driven by theories, whereas qualitative research is driven by stories. That's understandable. Of course, there are theories in qualitative research as well, and some of these exist prior to the study, and some emerged during the study. Quantitative research can also result in stories, so things that happened that were unexpected. That's usually a story that's resulting from some quantitative research. And then one more, I just thought I would throw it in there as a bonus. The way I divide or think of the world of research methods is that quantitative research studies numerical data, while qualitative research studies natural language data. Generally speaking. Of course, there are exceptions, but as a generalization, that's a good way to think about this jungle of different methods. And qualitative data can be turned into numerical data and vice versa. It's possible to convert one form to another. How reliably that can be done is a different question, but you can convert natural language data into numerical data and vice versa. Can anybody think of a simple way to take natural language data and convert it into numerical data?
Likert scale. Likert scale.
Likert scale, that's imagine I gave you 20 pages of natural language text printed. How could you turn that into numbers? I couldn't hear. Hot and cold?
One hot encoding.
One hot encoding.
Yeah.
What does that mean?
Going from taking calculated to the way it works and turning it into a number. So you can
Pages are printed, right?
Yes.
They're printed pages.
Yeah, it doesn't matter if they're printed or digital for this particular question.
You can do that, it's digital, or you can just chat it.
So
Put it in.
what would ChatGPT do? How would ChatGPT turn it into numerical data?
We'll find out. I'm not sure.
If you're not sure what to do, just throw it into ChatGPT.
Yeah.
You could just do a count for us.
Exactly. You sure you don't want to share your...
Yeah.
They trained you well. They trained you well. A simple exercise is just to count the frequency of the words. So every word has a frequency, how often it appears. Right? And you just count them. That has a name. Do you remember the name? Histogram, but in this special case, it has a special name when you're counting words and their frequencies. A concordance. It's called a concordance. It's not that important. You won't be tested on that. But anyways, you can generate what's called a concordance, which is a frequency of terms. Very, very typical kind of starting point for quantitative analysis of natural language processing, or natural language rather. Okay, any questions or comments about, everybody thinks they understand the difference between quantitative and qualitative research methods, roughly, approximately?
Yeah.
And if you're not sure what to do, just throw it into ChatGPT and see what happens.
Yes.
Okay, we'll stop here. There are no further questions.